We have about a minute. Good morning. Good morning, everybody. Welcome to the DB2Night show, episode number 276. Thanks for joining today. My name is Mohan Saraswatipura, an IBM Gold Consultant and IBM Champion, and I'll be your host for today's session. I'm excited to introduce you a topic that is becoming very interestingly important for organizations navigating through hybrid and multi-cloud strategies, right? Bring your own cloud for DB2 and Db2 Warehouse. Gopal, thank you for joining today. How are you doing?
I'm doing well. Thanks for getting me on this.
Oh, great. Thanks for jumping last minute. Right, get involved. This is your show. Follow us on X and the LinkedIn DB2Night show, hashtag DB2Night. And replays are available within YouTube and also our website. And please do join us in LinkedIn. The group is showcased on the presentation deck. And you will get all the updates via the LinkedIn as well as X, as well as the email. Disclaimer. I'm gonna let it be for about a few seconds. All right, tonight's show, we have BYOC. Venkatesh Gopal is going to deliver the session. This is a full packed session for today, which will have a lot of information about the Bring Your Own Cloud. And we have November 21st, AI Vectors, and then the last session for the year is going to be on December 19, 2025, about the DB2 Intelligence Center, where you can have the monitoring plugged in with your Watson X, and then gives you more information, flexibility, and all of the AI capabilities for your monitoring. That will be delivered, and DBI Performance Software Suite. This works for DB2 LEW, SQL Server, and it brings you a lot of capabilities of monitoring and troubleshooting, and also optimizing your hardware and software product suite completely. Please do follow us here and then take a look at the demo. If you have any questions, or if you want to see a real-time application with the DBI, please do let us know. We will be happy to set up a demo session for you. Thanks for our sponsor, Smart Tools for Smarter People, DBI. We will have a few polling questions, right, about DB2 and all that. I'm going to post it at this point, and let's look at. Okay, you will have questions coming over on your screen. Which DB2 version you're currently running? 12, 11.5, 11.1, or older? Okay, great. Collecting the responses. Closing the poll, sharing the results. Okay, so we have about 60% 12.1, that's good, and 80% 11.5, 11.1, 20%. We do have the software end of life cycle for DB2 11.5 published. It's going to be 27 April. So make sure you migrate all your databases to newer version. And 11.1 and 10.5 are all out of support. So please do upgrade those to a recent version. All right, what are your environment challenges? This is going to be an interesting question. Okay, distributing the poll, collecting the responses. All right, closing the poll, sharing the result. This is very interesting. It's performance, 100%. All right, I think Gopal is going to talk about the performance benefit when we go to BYOC, right?
Sure.
Awesome. next relevant question is about, are you running DB2 on EC2 or virtual machines in cloud? This will help in transitioning, Yeah. Collecting the responses, closing the poll, sharing the results. Right, 75% yes, that helps you in transitioning, and on 25% on-prem. Yeah, after you going through this presentation, like hopefully you'll make change the mind to go to cloud. Are you running Db2 Are you running Db2 Collecting the responses. Cool. Closing the poll, sharing the results. 40% yes and 40% no, and 20% no plan to migrate. I think we'll have some discussion around how BYOC is equivalent to RDS AWS, right, Gopal, today in the session?
Yeah. Yes, we can.
Great. All right, one interesting question today. So this is about, would you be interested in attending a hands-on immersion day session on DB2 BYOC? This will be probably about half a day or full day session with hands-on. If you are willing to participate, please do let us know. Key in your email address so that we can contact you to work with us so that you will get a hands-on experience on BYOC. Okay, please do type in your email addresses. We'll get in touch with you, and then we can discuss about the dates and time and all that, and we can arrange the session. This will get you a hands-on experience to work on BYOC. All right, that closes the poll, and I'm going to share the results. Yes, 20% definitely they want to participate, and about 60% wants more information. I can send you the details around. We can discuss it further about what we're going to discuss and what we're going to do, right? Thanks for the polling. Okay. All right, so coming to the session today. Before we dive deeper into BYOC, I'm pleased to announce Gopal, our special guest. He's the SDSM at IBM. Gopal is a recognized technical leader in the DB2 and DB2 cloud platforms with extensive experience in architecting enterprise scale deployments, hyperscalers, then cloud modernization strategies, and performance optimization across hybrid and multi-cloud environments. He has worked closely with customers globally to help them design, implement high availability, security, and efficient database architectures across AWS, Azure, GCP, and private cloud infrastructures. Today, he will be talking about the bring your own cloud deployment model for DB2 and DB2 Warehouse, key architectural patterns and the reference architectures, operational considerations, licensing model. We don't have licensing model, the discussion in place, but I think we're going to have a lot of documentation shared by Gopal at the end. And real-world lessons from successful customer implementation. And please join me in welcoming Gopal to the session. Gopal, thanks for joining us, and the floor is yours. I'm going to make you as a presenter.
Thank you.
At any point in time, if you have questions, please do post in the chat. Then we'll read it back to Gopal as and when we get time. We will try to address as much as possible. You should see a pop-up coming.
Yes, I do.
Awesome. It's your screen.
Thanks for the introduction, Mohan. excited to be here. I mean, this is my first time doing this virtual session. When it came out and somebody said it was DB2Night show, I really thought that it was going to be later and later. But, so there's something that I'm going to share my screen, and then so this is there was a little bit of a back and forth on this. One of my colleagues, Andrew, was supposed to do this. He's on a travel. He's on a plane right now, traveling somewhere, and I was able to get in and speak. Andrew and I kind of work together on our SaaS offerings. He's mostly focused on the DB2 transactional area. I'm focused on the warehouse aspects. But to the point that Mohan mentioned earlier, I think between us, we kind of look towards our current hyperscaler strategy, our offerings, both DB2, DB2 Warehouse, even in the context of hyperscalers, how would they work? In the context of OpenShift, how would they work? Look at deployment, scale, performance, security, all those aspects, and that's what we work together on. The good thing that has happened this year that we are going to talk about is the BYOC model, which we'll spend a little bit more time, but over the years, just to give a little bit of overview, DB2 SaaS, including both DB2 and DB2 Warehouse, has been a SaaS offering on different hyperscalers for about all the way starting from 2016, 2017. So about 8 years plus, we have been offered as a SaaS on many hyperscalers, IBM Cloud being one, where we have both DB2 and DB2 Warehouse as SaaS offerings. We also have a DB2 Warehouse SaaS offering on AWS. As Mohan indicated earlier, we do have a DB2 RDS offering on AWS, which is kind of the SaaS model on AWS from a DB2 transactional standpoint. And this year we did a little bit different on Azure. Though we could have done a complete SaaS, we were more focused on a BYOC model, and we'll talk about that model a little bit more in detail, but for a few reasons, because the customers that were on Azure platform wanted to the requirements were a little bit different than other hyperscalers, and that's because most of these customers or their companies or the group that they were a part of already had some Azure contracts where they could host infrastructure in Azure. They had good terms and conditions going on with Azure, and they wanted to draw down on those credits, right? So which kind of brought us to a different thought process and keep it at the same level of SaaS as a fully managed SaaS offering, but then offer it in a model where we are managing the environment that is running on a customer tenant, but at the same time provide all of the SaaS capabilities. And that's what I'm going to spend a little bit of time today and talk about those. So standard disclaimer from an IBM standpoint, just the disclaimer, our disclaimer, Mohan had one, those ours. Move on to the next thing. I think this is not new for many of you. You do know that DB2 in itself has got a spectrum of application categories. We have DB2, the transactional side that we call, which is used for very low latency application that can run multiple transactions a second, a minute, used by several big companies, enterprises across the world. And then we have DB2 Warehouse, which is kind of focused more towards the analytics part, where you have reporting, you have Cognos that needs to create dashboards based on analytics data that is stored, large amounts of data. We have a few customers that are running in the order of hundreds of terabytes, close to petabytes on this, and they're running analytics applications on top of it. So that's kind of the DB2 scope, but in the bottom, if you see what we have is our focus is kind of how to bring this to more cloud environments, make it deployable in a SaaS model, make it deployable in different Kubernetes platforms in the hyperscalers or even environments like OpenShift, right? So we do not only build our containerization architecture, deployment architecture on Kubernetes, but we also have self-managed environments can be run on those on OpenShift or any other Kubernetes platform. And our goal is kind of being available across the board, right? Everywhere. We call it all kind of deployment form factors, be it on-prem, which you said many of your customers are already there. You can do self-managed on any of these hyperscalers, and we did see in the poll that some of you do that, and be used as a SaaS service. And this is something I talked about already, so I won't spend too much time on this particular slide. We do have multiple deployment form factors, and DB2 single node, multi-node with HADR, which all of our SaaS offerings do currently offer. We do have infrastructure-based offerings. We call them IaaS offerings, which is pure scale-based that can be used on both AWS and Azure, on top of the existing on-prem deployments that you can do with pure scale. On the right-hand side, we do have the warehouse offerings, which is can be run in a single node topology or multiple nodes with multiple partitions, which we call the MPP warehouse offering. And all of these kind of are in some shape or form available in on-prem as a SaaS or somewhere in between as infrastructure as a service. Kind of moving over, like I mentioned earlier, we had SaaS for a bunch of years on different platforms, and as we were looking at Azure adoption, we were thinking about a little bit of a different model, and this model is now going to naturally lend itself and be applied to other hyperscalers as well. Is the BYOC model, right? We will talk about a little bit more about the BYOC advantages and BYOC. I wouldn't call it differences, similarities with SaaS, and a little bit of scope on what a customer could do, what is done by DB2, why BYOC is beneficial to a customer, and so on. But this year, sometime in June, July, we released the IBM DB2 as a service, BYOC SaaS, which is now available on Azure for both DB2 and DB2 Warehouse. So again, like I mentioned earlier, the one focus for us was, even though we call it bring your own cloud, we still wanted to kind of keep it as much SaaS as possible, right? So we do take care of deployment of the BYOC offering, SaaS offering in a customer tenant, but at the same time, we take care of everything else, right? So you don't have to worry about the SaaS services health. Monitoring is taken care of by us. We send metrics data over from the SaaS offering that is running in your tenant back to us. We will take care of all of the updates, right? So even though we run a bunch of components in your environment, we can update all of them. We can do database updates. We can do engine updates. We can do cluster updates and everything else, right? So all of this is going to follow the exact same SaaS model like we do for a fully managed SaaS. BYOC is going to be no different. Like the norms, I know there is a 12 factor for any SaaS service. We cater to all of those, the primarily being a fully managed SaaS. Our thought process is we take care of everything. You just focus on your apps and then setting up your schemas, your things and your reports and so on, but we'll take care of everything else from a database standpoint, be it deployment, management, scale, and anything else, right? So the offering itself is scalable and elastic. This applies to both the DB2 and DB2 Warehouse offering. You can scale horizontally. You can, in case of DB2 SaaS, you can scale vertically. You can go up the number of cores. In case of DB2 Warehouse, you can scale both horizontally and vertically because you can go more number of nodes, or within the same node configuration, you can scale up a little bit if there is room in those particular nodes. Highly available. Both these offerings are supposed to be are highly available in nature. In case of DB2 transactional model SaaS, you can set up HADR, you can set up HA, you can set up DR along with it. In case of DB2 Warehouse, it's highly available. it's running in multiple. If you're running in a multiple node configuration, if something happens to DB2, there is automatic DB2 restarts happening for the particular partition or node. If one of the node goes down, it's all taken care of by the SaaS service itself. The key thing about the two aspects that are a little bit different in the BYOC model, or the fourth part of that I state over here is data stays in your account, right? Like I said earlier, there were a couple of things that customers were really interested in. One is being able to draw down on their existing hyperscaler credit model. The second thing is they were worried about security posture and data residency. In this case, the data totally stays in your hyperscaler tenant or account, right? It doesn't leave anything. It doesn't leave that domain or that boundary. The customer has complete control or complete control of the data, complete visibility to the data, and then they can also apply any guardrails and things like that that they need on the platform. Reliability is built into the SaaS service, so we do just like DB2 SaaS. We take backups and which are snapshots. On the DB2 on Cloud service, the snapshots along with the logs that are copied to object storage provide you point-in-time recovery and so on and so forth. In case of Warehouse, the snapshots are used, and the snapshot can be used for recoverability aspects as well. So a little bit more in depth on what the offering on BYOC does. So it does pretty much whatever the offering on the SaaS platform does today, right? The few new things to call out would be the latest DB2 version, which is a good thing that it looks like many of you are using the later 12.1 version. So we on the cloud. The one thing that happens on DB2 cloud delivery model is we are always on the latest and the greatest version of DB2. On all of our SaaS and BYOC, we are on the latest DB2 v12.1.2. At the time when the next mod packs and all are available, we'll automatically be getting upgrades to them. So DB2 always at the latest version. The scalability, very high CPU and database size. You get about 4 terabytes of storage. These are running in multiple node types. There is a lot of Azure instances that we support. Similar to what AWS RDS supports, AWS RDS allows you to deploy environments on a bunch of node types, which is what we are exposed on BYOC Azure too. It doesn't bind you to a particular Azure instance type or an Azure VM type. We support a lot of these options, which I'll have a couple of screenshots later. You can grow storage up to 256 terabyte. The initial spec 128 and 4 terabyte was the RAM aspect, and you can grow your database size to about 256 terabyte. There is about 4 disks that are used, and the disks are striped. Each of the disks can be grown, which gives you not only storage size, which is much bigger than what is supported on IBM Cloud right now, it also gives you a good knob on the IOPS, which are required for performance from a storage standpoint. So we have not only growth in storage size, but you can also grow in terms of IOPS as well if you need to. Highly available. We did talk about the 2 HA nodes and 2 DR read replica nodes. There is going to be support for across regions coming in 2026. You can apply updates to DB and DBM's registry profile. One thing that we realized is customers would want to bring their own backups from an on-prem system or any other system and then seed it into BYOC on Azure. They do something similar on AWS RDS as well. And that's a feature that's going to come in anytime now. And like I mentioned earlier, in IBM Cloud, in the initial generation of DB2, we used to support DB2 backups, but now we have switched to a snapshot-based backup with point-in-time recovery using the logs. So that is a feature. And since you are deploying in your own account, There are some extra things that we could do that we were not able to do in the SaaS service, which is the ability to be able to run external routines and so on as well. I won't spend too much time on these charts because this is something that I touched on earlier. What I want to focus here on, if you can see the machine types, there is a lot of machine types that we support. You can see on the screenshot that we have 48 vCPUs, 384. The list is much wider than that. So this lets you use different machine types. You can change an instance profile from one to the other, and then we'll be able to move you from a smaller profile to a larger profile. The other aspects are the storage, which I said earlier. You can not only scale the storage, but you can also change the IOPS knobs on volumes as well. We did talk about the reliability aspect a little bit. Like by default, the service is going to come up with a daily self-service snapshot backup. On a daily basis, the service itself will provide snapshot backups that are taken. You can augment it with your own on-demand snapshots if you want to. You can do a self-service snapshot restore. On the back end, we do take additional backup for disaster recovery purposes, but if a region goes down or something of that kind, but if you have HADR model, you really don't need it. The archive transaction logs to blob storage provide you that with the point-in-time recovery or point-in-time restore aspect of things, right? So this kind of makes the system very reliable. You can go back to a point in time. If you have lost some data, you can go back to a point in time, and all of this is self-service and basis. Highly available. We do support, like I talked about earlier, you can have HA. You have a single node, which you can have a single node, or you can have a single read-write node, which is the primary with a read-only replicas, which is the HA node. You can easily add HA to an existing instance. For example, if you started with a single node deployment and you want to add HA to it, you can easily do that. The HA standby replica can be used for read-only access, and it also kind of works in the larger context of if something happens to the primary node, everything else kind of works seamlessly from there, in the sense that if you have ACR built into the applications can then connect to the secondary, and then we take care of automatically switching roles on the back end so that the secondary takes over as the primary, and then it does all the work seamlessly for you without you having to do anything. The survives disaster is something that I mentioned earlier. It's going to come in towards Q1 of next year. This will let you set up a DR environment. The benefit of this is that if the two zones go down, then automatically you will be able to switch to, you can manually switch your application over to the DR environment until the primary region which failed comes back up. What we have done a little bit different, switching gears a little bit, is what we know that customers would be more accepting, and since we have to deploy a BYOC in an Azure environment, what we did is that we have done a lot of integrations with Azure native components, right, or Azure ecosystem itself. So all of the data that we use for the BYOC deployment is, and all of the interactions that we do in the BYOC platform happens within the Azure ecosystem itself. So for example, we use Azure Monitor. All the logs and stuff like that happens in a BYOC deployment goes to Azure Monitor, which our SRE can get access to based on the problem determination that they have to do for a limited time, and then they can go and take a look at the logs. And we'll talk about how that is done a little bit later. Via Azure Key Vault, all information like secrets and stuff like that do get stored in Azure Key Vault, again at the customer tenant. We don't do any cross access for those. The thing being, it all being in your Azure VPC, It helps you set up any special Azure network security groups and all that you need to do from a customer standpoint. We set up a bunch of things, but you can set up your own security policies and stuff like that on top of our deployment. We did talk about snapshot backups and transaction logs. They go to Azure Blob Storage. By default, when an Azure Premium Disk or Azure Disk gets backed up, they take care of the snapshot, movement of the snapshot to something in Azure, and we take care of archive log transaction to Blob Storage. We also ensure that from a deployment model, the customers do get a visibility to what we do. And everything is done within an Azure scope, right? So we make use of Azure IAM. We create managed identities in Azure. We make sure that we have limited resource groups in Azure that get created. Data access is limited for different entities based on a resource group scope and so on, right? And finally, all of this is kind of integrated with the Azure Marketplace, and it helps you, like I mentioned earlier, it helps you use your Azure credits for acquiring the service and then using the service thereafter. The benefits, like we spoke about earlier, what are the big things for BYOC, and why did we adopt this BYOC model, right? The first thing is we wanted to keep all the terms of a SaaS as is, but it gets deployed onto the right side box, which is a customer-owned account. What IBM does is IBM runs something on an IBM control plane. The job of the control plane is to mainly do the initial orchestration. After the orchestration, it gets metrics information back about the health and so on, and then the control plane is used for things like updates, upgrades, and so on and so forth. But in the model, if you can see, all of the things are running in your in a customer-owned account, right? What this means is that we still run as a complete SaaS, but you get complete control of your data and security posture, like we talked about earlier. You know what is running, you know what infrastructure is getting used, you know what components we have deployed. You have got complete control of adding any security aspects on top of it, right? Data sovereignty, compliance, and residency, all of these are met. Like some companies may have very strict postures for data residency and data sovereignty. All of those are met by the BYOC model. In some cases, what happens is that there's a lot of egress. So if you're accessing data from, say, DB2 that is running as a SaaS to your own environment, there is egress charges. In a BYOC, it is all running in your VPC. It can be easily shared with your application stack. There is probably not going to be much egress charges. Wide range of supportable regions. This is a kind of a big advantage from an IBM perspective. The deployment model that we have created, or the deployment architecture that we have created, allows us to work with any customer, and if the customer has the requirement for a new region, it is very easy for us to deploy BYOC in that region, right? Because again, it is the customer's tenant that has to have that region support, or they have to make sure that the VM types or the Azure VM types that we use are available and things like that. But our BYOC model can be easily it can just be used, right, without having to make any changes. On the other hand, if I were running a SaaS and a customer request comes in for a region, then I have to make sure that I create a SaaS deployment architecture in that region, and then the customer can deploy an instance. In this case, we just use our templates, we just create our deployment stack in that region, and then the customer can run DB2 instances there. The other two parts that I already spent time on, it can be easily integrated directly to your cloud account. It's actually it is integrated to your cloud account, and you can work with your different application stacks and everything easily without having to do any new work. And we talked about some of the enhanced capabilities. So I'm going to skip this slide because I've got a couple of screenshots that I can talk about this a little bit more in detail. This slide talks a little bit about our what happens in the 3 different deployment models. A hosted SaaS is something that is completely managed by IBM, right? So there's a fully managed SaaS managed by IBM. So you can see that everything is done by IBM. The DR part is something that the customer has to handle in the first column or the second column. The customer has to set up their DR instance and then be able to switch things if the region goes down. In the bring your own model, as you can see, there is a little bit of more play that the customer has to do in a couple of areas. We already talked about the security monitoring of posture. The customer has full control over it. The infrastructure location, the customer account, and the cloud provider plays a key role. But as I mentioned earlier, it lets us deploy in any region for that matter. DR alerting is IBM and customer. The cloud infrastructure support, which is the last column, is a little bit interesting in the sense that if it were a fully managed SaaS, right, and IBM is running a fully managed SaaS on AWS or Azure, and if some problem occurs in the infrastructure, then IBM will directly work with the hyperscaler. But in this case, since you are running in your tenant, and if there is an infrastructure issue, we will direct you on what the problem is, but we cannot open tickets on your basis in the hyperscaler. So the customer has to work with us in making sure that we get the proper responses from the hyperscaler team, and then we can work on RCA together and so on. So that's kind of what the slide talks about in terms of scope and responsibility and how things are different from a BYOC perspective. This is a little bit of in-depth detail on how we have architected our BYOC deployment. What we have done here, there was a very small block diagram earlier which talked about the control plane and the data plane. This slide talks about the components that go in the orchestration process. So essentially what we do is that IBM on the left-hand side, we are running this control plane. So this blue block on the left side is our control plane. So this control plane is where customer comes in from the marketplace. Customer then goes and triggers what we call as the deployment of an instance / data plane and then DB2 engines. So what we do is that the very first time when the customer comes in, they have to make sure that their environment is ready to host, to create a DB2 data plane and then DB2 instances within it. So we have a pre-step, which is kind of seeding the customer tenant with a set of Azure policies, Azure roles, Azure components, and so on. And then what happens is that once that first seeding is done, then the control plane and the data plane, then the control plane and the Azure side can communicate and then orchestrate the rest of the things. So what we set up as part of the whole BYOC deployment, we did talk about the ecosystem part earlier. So we used Azure Monitor, we use Azure Blob functions, which are kind of runtime functions which help us go through the orchestration process. We use serverless functions, which is Event Grid. We use Azure Logic functions. We use Azure Managed Prometheus, which is where the metrics are sent from the data plane to us. These are kind of things that happen. These are the alert information, stuff like that. For example, if DB2 is running, how much memory DB2 is consuming. If DB2 has some issues, all of those come in the form of alerts for our SRE team to act, right? Most of the HA components and stuff like that are running in the cluster itself, and they should be healing themselves. But from an operational standpoint, we need to know that something has occurred. So those alerts will flow to us so that our SRE team is aware of what is going on. So this whole kind of architecture that we have built kind of needs no connection between the control plane and the data plane. What we use is a component called the Azure Service Bus, which is like a message broker, and all of the communication happens through this message broker. So there's only 2 communication points. One is messages flowing to the message broker to do any orchestration and deployment, and the other thing is any metrics that is flowing back to us. So as you can see, there is no data leaving out of your environment other than metrics, and there is no direct connection to your environment other than through the message bus. So we feel that this model is very unique and IBM only at this point, but it also gives us the ability to run a full SaaS service like the way we would do if all of this were running in an IBM SaaS environment. So this component is a little bit key, which is why we wanted to drill down a little bit onto this. So once things are deployed, our SRE team needs to now and then get onto your or look into your Azure tenant for some issues, right, that are not self-healing or that need a little bit of more interaction. Azure has this offering called Azure Lighthouse, which helps cross-tenancy based access. And what we do is that what it helps us do is that set up DB2 SaaS specific resource groups on a customer account. And using this, our SRE team will be able to go and look at, say, just Azure Monitor. If they want to look at the Kubernetes cluster or the DB2 containers and pods running, they'll get that access. So Azure Lighthouse provides us that mechanism to get on and look at your system. And like I mentioned earlier, all of this is for a very time-limited amount, right? Only for the time that the SRE team needs to look at, diagnose the issue. After that, the whole access from a Lighthouse standpoint is kind of taken away from that SRE person. So it is just for the duration to diagnose the issue. Lighthouse gives us the access, and once the diagnosis is done, we go ahead and the user is the access is revoked from the user. I'm going to skip through all of this because this kind of details a little bit on what we have already talked about, the deployment model. We have two zones where each zone has got a DB2 instance. They're working through HADR. The backup, the snapshots and backup and archive logs are happening from the primary. The secondary is just playing logs, and then it can be used as a read replica. We talked about the 4 volumes that can be used. It gives you not only the storage bandwidth, you can go up to 240 terabytes of disk views, and at the same time you get IOPS. Like I mentioned earlier, IOPS are a key knob to get performance. Customers can go up and down on IOPS. You can scale storage size on an automatic basis and so on. HA architecture, the default SaaS HA architecture applies to BYOC here. You have a primary, you have got DB2 getting connected to the primary. You have a read replica that the customers can connect to. In case the primary goes down, automatically we'll take care of the switchover. We will make the secondary the primary, and then the secondary starts getting a snapshot backups and everything else taken. And when the primary comes back up, things just get swapped over. Sorry, the previous slide, I just skipped on it. So when the primary comes up, that becomes the previous primary comes up, it becomes the secondary, and the new one continues. The previous secondary just takes over as the primary and then continues thereof. All of this is orchestrated. The point that I want to mention is it's no different from our existing SaaS deployment, so the same deployment model is continued. Switching over to the warehouse aspect of it a little bit, again, everything remains the same from a SaaS standpoint. We continue and extend whatever we offer in the SaaS. In warehouse in particular, we focus on the NPP model. We have multiple nodes running, and each node in turn could handle a number of DB2 partitions, and we have scale, HA, and everything built into the system. Just like DB2 SaaS, we support all those factors. The one thing that I want to add on DB2 Warehouse SaaS, this has been introduced since 11.5.9 and continues in 12.1. DB2 Warehouse SaaS now allows DB2 native tables to be created in object storage. You might all have heard about it, but in the SaaS platform, we kind of talk about it, and many customers are using it primarily for the reason being block storage can be more expensive as compared to object storage. Object storage gives the same performance benefits or better performance as in some cases as compared to block. So we have kind of, we don't call them as two separate tiers. We just say that customers can use block or object storage, and object storage works with the same performance. The node types that we use for warehouse includes NVMe disks, which acts as a layer of cache for the object storage data, which is how we get better performance or equivalent performance. We now have support for data lake table support in warehouse, and a bunch of other features, right? And all of these feature sets do extend to Azure as well. So the ability or the spectrum of compute scale and storage scale is in fact limitless with Azure Blob support. You can, we do support Azure Blob storage. You can increase storage automatically. Backup and restore makes use of Azure Blob backups. You can pause compute. If you don't need to use the compute for some time, you can pause the instance and then you can resume the instance. In the context of Azure Private Connectivity with Azure Private Link, which should be the same for DB2 SaaS as well, all of those aspects are supported. I'll just talk about the node types and so on. We do support node types that are large enough to be able to support the spectrum that I talked about earlier. You can go up to 4,000. We had a number about 4,800 vCPUs, so you can have about a 60 node environment with about 2 DB2 partitions running in each. So this is what is the node configurations you can go depending on the model type. So you can see the size that it can grow to, and the number of cores it gives you, the amount of memory it gives you, and the data that you can work with, right? So we do support very large environments in BYOC as well. Mohan, a quick time check. Can I have 5 minutes to just walk through a deployment process and then we can do Q&A?
Oh, sure. Yeah, we have time. So we have we still have 30 minutes time.
Oh, we still have 30 minutes time. Okay. So the key thing over here is that how we deploy, right? Like I mentioned earlier, there's a little bit of a different deployment model than a SaaS. If I were deploying a SaaS service, you would just come to the IBM Cloud Catalog page, or you would come from the AWS Marketplace or Azure Marketplace and say, provision me a DB2 instance. Provision me a DB2 instance in AWS, and we just go and provision a DB2 instance in AWS, or a DB2 Warehouse instance in AWS, or a DB2 instance in IBM Cloud. The provisioning happens, it all runs in the IBM Cloud account. You just get endpoints. But the BYOC model is a little bit different, right? The BYOC model needs, like I said earlier, we have to first get to your tenant or your account. We have to first seed the account with some initial components, which gives us permissions to be able to deploy things through the message bus or the message broker that I shared in one of the architecture slides. And then after that, you go and deploy instances and a data plane after that, right? So data plane and instances in that order. So the first thing is you start off with an Azure Marketplace. Once you get to an Azure Marketplace, you will be able to see the DB2 offering there. And then once you click on, say that I want to get a plan, you will be getting a subscription and a link to the IBM SaaS console. So this is where you get brought into. You get a subscription, and then that subscription shows up over here. Once a subscription comes up, or if you don't have a subscription, right, you have to set up your IBM SaaS account first. You set it up, and then you submit and provision. Then you get into the IBM SaaS console. And over time, we are trying to make this experience a lot simpler, and there'll be a lot more discussions that probably Mohan will have in his future sessions, or our IBM team will start talking about. We want to make this experience more seamless for customers. But once you come to the subscription, what you need to do is the first seeding of on the customer tenant side, right? So you got a subscription, you're in our SaaS console, and then we start getting to the part of how this whole thing is going to get set up. So what you do here is that the first thing is since we are going to work from a BYOC standpoint, it's an IBM tenant that needs to communicate with the customer's tenant. We need some tenant consent going on. So what happens is that you have to feed in your tenant ID and your subscription ID. And then once you feed this, we do an approve Azure consent. It is mainly an app consent for us to start creating an ARM template. The ARM template does the initial seeding that we talked about. So the ARM template will say, I need to create these many resource groups. I need to create these many managed identities, and these managed identities will have access to these resource groups. It'll go and create the Azure monitor. It'll go and create the Azure service bus and those kind of different things, right? But this is all not done as a single step, right? So when you click on Azure approve app consent, you get taken to a page. You accept those permissions, and when you accept those permissions, what we do is we come back to this page, and then we do what is the deploy, right? This deploy will actually give you what we call as a ARM template deployment. It will then, because of the application consent we got, it will open up this deployment. So this deployment can either be downloaded by you as a customer, downloaded by you, and then you can take it to your Azure infrastructure team or your Azure team and say that, hey, this is the deployment template that we got from IBM. These are the components they're installing. These are the roles that they are creating, IAM roles that they're creating. Go and take a look at it to see if there is something of concern. And after they give the consent over, you can bring that deployment template and you can run it, right? Or you can automatically run it. You can go through those steps 2 times. You can come back the second time and then go through the same process and then recreate you the template, and then you can just automatically deploy it over here once somebody has given you the consent and approval on it, right? So what this does is that this goes ahead and creates all of the initial artifacts that are needed. All the components in the Azure ecosystem that we talked about to be able to create the next set, which we call as the data plane. So once the screen gets done, once it is deployment completes, we come to this phase that we call setup data plane. So this setup data plane, it goes ahead and then does the setting up of a Kubernetes cluster, which is an Azure Kubernetes cluster. And then it will go and set up the node templates or the node groups that are required for DB2 instances. Nothing will be provisioned. It'll just create those templates, and then it'll be ready for an instance provisioning. So the next step, so first thing is consent to the application, and then seeding your environment, seeding your tenant with, like I talked about earlier, right? It creates the resource groups, the VNet, the managed identities, custom roles and role assignments, all of these that are required to set up the data plane. So then the setup data plane is going to go and create the Kubernetes cluster, create the node templates, create Azure blob account, and so on and so forth for DB2 instances, right? There is actually no data and stuff created at this point. So even if you go through these set of steps, the cost or something from a end customer standpoint should not be that much at all. And actually what we have done is in our documentation, we have put together a bill of materials on what all we deploy so that customers have got a clear understanding of what happens. So after this particular stage, we go ahead and set up the data plane, right? The data plane setup, since it sets up the Kubernetes cluster, this is a one-time thing. This process can take about 40 minutes or so, right? Because we are setting up the Kubernetes cluster. The cluster has to be set up. The initial workers that are needed for this cluster get set up. And then the Azure service bus that we talked about, the Azure monitor, all of those are already done. But now, at this point in time, the communication has started going from the control plane through the service bus to the backend, and this is the one that takes care of provisioning the data plane. So first two steps: set up the communication channel, seeded, set up the communication channel, and now the communication channel is being exercised on, and that the data plane is now getting deployed. When the data plane gets deployed, then you can start deploying DB2 instances. It'll show you the DB2 engine page where it sees that there are no DB2 engines. And then after that point, you can go and start deploying a DB2 engine. This slide kind of tells you, so if you can see if you have provisioned a DB2 engine using the IBM Cloud Catalog, it is going to be very similar. So you can give the instance a name, you can use the profile, you can set up HA, all of the capabilities, right? And then you can set up an initial user and password, and then deploy the DB2 engine. And that kind of takes you to engine provisioning is very quick because we already have created the node templates and stuff like that. What it does is that it creates it should be a 10-15 minute activity. It should just create a node of that type. All the charts and everything else are getting deployed already, so it should be then able to provision an engine very fast from there. You would go through the sequence if you want to deploy multiple DB2 engines. Note again, the data plane deployment is a one-time thing. You just go and deploy engines. We also have provisions for you to delete engines and so on and so forth. You can also delete a data plane and then recreate a new one. I mentioned earlier, we take care of all of the updates, upgrades for all of these components without you having to do anything, and that's what makes it more of it's a SaaS. But again, the SaaS is running in your environment. We manage it, we take care of everything, and all the DB2 SaaS capabilities are already available. So that kind of sums up what, this is the last scene, right? Once the deployment is complete, like I said, you will be getting a endpoint to the engine. You can go into the engine console. All of this, again, is running within your VPC. So you should be able to access all of it from your existing setup, right? So you don't have to do any new setup. The assumption is, if you're deploying a BYOC environment in your VPC, your hyperscaler integration with your on-prem or anything of that kind should already be done. So you don't have to do anything new to connect to DB2 or any new checks that you have to do or any network setup and so on. So that kind of sums up what I had to talk about. Mohan, I mean, if there are questions or if there's anything else, we can open up.
Sure. There are no questions here, but a couple of things. One is about the HADR solution.
Sorry, Mohan, you broke there.
Oh, sorry, it went again, but
yeah.
The HADR solution, is that the native HADR with Pacemaker when we go with BYOC?
Yeah, it's a native DB2 HADR, whatever DB2 HADR works off of, right? Nothing new. The only thing is that when the failure and stuff happens, we just toggle the nodes based on what we have for in the SaaS model. We have got something called Debroni that takes care of switching the environment.
Okay.
Yeah.
Oh, in that case, we don't really have to set up the load balancer and everything from Azure. IBM takes care of all of setting it up, right?
Yeah, the routing and all in the backend is taken care of. But if you have ACR set up, that'll just work. Yeah.
Okay, great. When it comes to MPP, is that going to be multiple virtual machines, or you have a big virtual machine and then create a logical?
No, multiple virtual machines. That's what I showed, right? We can. So, for example, what we do is that depending on the model, you can pick up. You can scale up and down within the model.
Right.
So let's assume that you have picked a medium model and you have picked up 3 nodes as the initial starting point, right? Then you can go up to 4, 6, 8, 12, 24 nodes if you want to, or you can go down. So the way the deployment is that we have a fixed set of partitions. So when I talk nodes, I know I talk a little bit different than what the DB2 team calls as nodes. For me, nodes in the SaaS model, I map it to instances. Partitions are what are the logical partitions that run inside, right? So we keep the logical partitions always the same in a deployment model. So let's assume that I have a 24 partition deployment model, right? I can run it in 3 nodes, then each node will be catering to 8 partitions. Now, if I move to a 4-node environment, each partition will cater to 6 partitions. Each node will cater to 6 partitions. So the advantage with that model is that I'm able to use of DB2's MPP and the whole degree aspects and stuff like that, and still run a powerful environment, but I don't have to redistribute any data. I just have to switch volumes.
Oh, got it. When it comes to licensing, do you want to touch base a little bit on licensing when?
Sure. I think sure. I can talk a little bit about it, and as I said later, we can probably post a set of links in this when it goes out. I mean, there are a couple of things, right? So the key thing for us is when it comes to this BYOC thing, we know that the customers are going to have their infrastructure spend going to Azure directly, right? So in one of the pages that we talked about here, and let me see if I can bring up the link, you will see that in the Azure Marketplace page itself, that is when you go to the Marketplace and then when you say you want to subscribe to DB2, and let me see if I can bring up that link while I'm speaking. So you subscribe to what you call as RUs, right? So which is called resource units or a consumption model. That consumption model generally includes a couple of things. One is the DB2 that you're going to run, which say if you're going to run a DB2 with 2 vCPU, there may be some DB2 licensing charges plus the SaaS charges, right? Because we are managing this environment, we are doing updates, upgrades. So those two are combined into what we call an RU, and that RU is what you buy in terms of subscriptions. So you can, depending on the size that you deploy, you can buy whatever. The good thing is that I think we have in this BYOC, I didn't call it out or state it. You can use DB2 and DB2 Warehouse interchange. You can exchange with the RUs that you buy, and you can use them, and they get built to the same consumption thing, right? So it is just that the amount of RUs that you draw may be more for DB2 Warehouse, depending on the size you're running, and less for DB2, or vice versa, and all of that works, right? You did ask me a good question earlier about if I have my DB2 license, how does this apply? I think that is something that the product management team is working on right now, and then we will be able to talk about whether my existing DB2 licensing changes this. I know existing DB2 licensing also applies in the case of Amazon RDS. They're working on a similar model for BYOC Azure.
Oh, that's great. Cool. Regarding, we talked about the immersion day, right? So if we get people around to try it out, is it going to be a half a day or full day program?
So we can do an immersion day, and I think there were many people that said we need more details.
Yeah.
Like if you saw in the last few set of slides, there is definitely something that has to happen on the customer's Azure tenant, right?
Right.
So if those prereqs are met, then the immersion day could be as short as half a day, right? Because if the prereqs are met, then we should be able to get things deployed. We should be able to go and kick the tires, right? But if those prereqs are not met, then that kind of makes things a little bit longer. But half a day should be enough, assuming what we could do is that we could probably give an initial. If we are going to go with this immersion day, we can probably give an initial download of the template so that people can start getting feedback from their teams. And that might be enough for us to jumpstart it or kickstart it. Yeah.
Yeah, that sounds good. Yeah, if you need more information, please write it down in the chat, or you can email me. We will discuss further. Gopal, thank you very much for conducting the session. This was very helpful to understand. I think we have a couple of questions. Let me go through. What kind of backup recovery strategy do you use? Third-party software or Azure services? What kind of security management software do you use? Azure native or Guardian cloud version? Couple of things about the backup and recovery and the security with the monitoring, Guardian-like solution.
Yeah, so I think let me take the easier one first. On what kind of backup and restore, we just, like I said, right, we use snapshots, right, and then we use the logs that are sent to Azure Blob, right? So it's an IBM solution. It's an IBM solution that we kind of on most of the SaaS environments. There's a reason for us to switch to the snapshot plus the log shipping mode, right? You know that DB2 backups can sometimes take time, depending on the data that has changed. Even incremental backups could take time. What we have seen that most of these vendor solutions that support snapshots of block storage volumes, and it also gives us some, like I mentioned, some of these snapshots get shipped to object storage, or they can be restored into another environment and so on. So the solution is kind of IBM built, but I think many vendors now use this for hyperscaler solutions. A combination of snapshot plus shipping logs, and then we just use that for we then just use it for the SaaS services. DB2 backups are still done, but they are only in case of some requirements. If there is some regional disaster or something, how we can recover, we just do DB2 backups on top of it. On the security thing, the response would be is if the question is how do I manage security or how do I get access information for my instance, I think the response would be like you can, and I'm going to say this a little bit with a little bit of hesitation, but we are looking into it more in detail. Like I said, we will send all of the information is in the customer's domain, right? The customer can send it to any of their own secure platform like Curator and stuff like that. So from a service standpoint, from a data plane access, from everything else, they can send it to their Curator or their environment, right? Like I mentioned, we have Azure Lighthouse access. So with Lighthouse, they can know who from SRE accessed and how long. That's two. The third part, like if you were to integrate something like Guardian, I'm thinking like something like the exit stuff or for access of the database itself. I'm not 100% sure on that whether we have provisions for doing that yet, but that could be integrated also if we need to do, right? We have integrated it on a SaaS model for a few customers, but I don't think we have come to that part for BYOC. So that would be the kind of three-pronged response to that.
Got it. That's majorly for the auditing purpose, DB2 audit or native audit, something which is DB2.
Native audit will work fine, right? Okay. DB2 audit will continue working fine. DB2 audit is not a problem, but if you want to do a Guardian. Like the STAP and then guard exit stuff, that needs a little bit more. Yeah.
Got it. The other question about the recording, yes, the recording will be made available at the end of this session, most likely by end of day today or tomorrow. I think that's it from the questions. I don't see anything coming over. I'm gonna take the screen back again for a few minutes.
Sure.
Again, Gopal, thank you very much for helping us today with making us aware of BYOC features, patterns, and availability options, performance considerations, cost optimization, all that. That was a fantastic opportunity for us to learn from you. Thank you again. All right, today's night show, sponsor DBI, Smarter Tools for Smarter People. This is one of the tools which gets you database monitoring solution, and the sizing, capacity planning, everything put together in one. So this is a web-based, lightweight solution that gets you powerful dashboards like the one I'm showcasing here. It gets you a dashboard, execution time, statistics, trend chart, and workbench advisor, and also simulation of the index. For example, if you want to deploy a new index recommendation based on DB2 index recommendation, DBI product will go and then analyze all the workloads, not just about one SQL. We'll analyze all the workload across the database to figure out if this new index is going to cause any degradation in the performance. That's one of the best features which is available within DBI product. Please do get in touch with us if you need more information about. Okay. All right. That's good about it. And commercial show sponsor, as I said, is a DB2Night show, smarter tools for smarter people. And with that, I would like to thank everybody for joining today. And then today's recording session and presentation slides will be made available in our website, and we'll be posting that in the LinkedIn session. Thanks again for joining, and we'll talk again next month. Thanks. Bye-bye. Thanks, Gopal.
Yeah, bye.
Bye-bye.